Hello everyone. In this section, we will discuss about the recommendations for neural network. We will understand the various aspects of neural network training which can be implemented using the TensorFlow. So these are the topics we are going to cover. First, we will discuss what is backpropagation. After that, we will discuss the types of backpropagation, and then next we will discuss the learning rate decay. In the end, we will discuss the max pooling and the LSTM model. First, we will discuss what is backpropagation. Basically, backpropagation is one of the important concepts of a neural network. Basically, our main purpose is to classify our data best. For this, we must update the weights of parameters and bias. But how the question comes to in your mind is that how can we do that in a deep neural network? So the answer is, in the linear regression model, we use the gradient descent to optimize the parameter. We use a gradient descent algorithm by using backpropagation. The main features of backpropagations are the iterative, recursive and efficient method through which it calculates the updated weight to improve the network until it is not able to perform the task for which it is being to be trained, and also the derivatives of the activation function to be known as network designs that are required for backpropagation. Now we will discuss how backpropagation algorithm work in neural network. The input layer, that is x1 and x2, that receives the inputs x, and through the pre-connected path input is customized by using actual weights, that is w1 and w2, where the weights are selected randomly, and output is calculated for every neuron, and the output is calculated for every neuron from the input layer at the hidden layer, and the output data has arrived at the always in the case of output layer. Basically, the main purpose of to decrease the error, adjust the weights by going back to the hidden layer from the output layer. It repeats until the desired output is obtained. So basically, in this given figure, there are two inputs, that is x1 and x2, with one output. So there is no hidden layer. Along with that, we have mentioned the weights and bias respectively. So the bias is defined as the input neuron to the output neuron, which has a stable value that always increase with +1. So the both and bias are defined as a parameter. Now we will use the sigmoid activation function and assume the output layer, and the equation will be fx is equal to 1 upon 1 plus e raised to power minus x. And the equation is t equals to x1 into w1 plus x2 into w2 plus b. So here is the table we have created. In this equation, t is the sum of products between inputs and its weights. So as you can see that this figure we have created x1, x2, we have inserted the value in a float manner, and we have assigned the desired output. Now we will assume the final values for bias and weights. So we have considered as a w1 01, w2 08, and assume the bias value, that is 1.45. Now let us train the network and check how the network will be predict the result of the sample based on the given arguments. So basically, I will understand you that training has two phases. The first one is backward and another one is forward. So first we will understand the concept of forward pass. Basically, the input of the activation function will be the sum of the product between weights and the inputs, and that will be considered as x1 and x2, and it will return the output of the neurons. You can see in previous slide we have created the equation, that is t equal to x1 into w1 plus x2 into w2 plus b. So we have already mentioned in the values in a table. So after that, we have inserted the values as per the table. X1 value will be 0.5 and w1 0.1. So both, when we have calculated this equation, the value will become t equals to 1.98. So now the value will be 1.98 is then applied to the activation sigmoid function. That equation is ft equals to 1 upon 1 plus e raised to power minus t. So we have inserted the t value in it, that is minus 1.98. We have calculated the value of e raised to power minus 1.98, that is 0.138069, and we have added the plus 1. After that, the value will be ft equals to 0.8786, which is the sigmoid result. So the output of the activation function from the output neuron reflects the predict output of the sample. So now we will discuss the difference between the desired and the expected output. So the equation is E equals to 1 upon 2 desired minus predicted raised to power square. So in this we have assigned the value that is desired output, that is 0.3, and the predicted output, that is 0.8786. We have subtracted values and the value comes minus 0.5786. So after this we have predicted the value, that is 0.16743. So now we will discuss why do we need back propagation. So basically this technology helps the user to adjust the weights to the network connection for minimizing the result of the propagation with some value that we help simplify the network structure by deleting the weights link, so that trained network will have the minimum effect. And this method is especially applicable in deep neural networks which work on projects like speech and the image recognition. So basically it functions with multiple inputs using chain rules and the power rules, and also it will calculate the gradient of the loss function with respect to all the weights in the network. Also it minimizes the loss function by updating its weights and with the gradient optimization method. So now we will discuss the types of back propagation in neural network. Basically there are two types back propagation, that is static back propagation, and the second one is recurrent back propagation. In case of back propagation, the result is generated due to the mapping of the static input value, and it also used to fix static classification problems like optical recognition. While in the case of recurrent, this propagation is directly forward or until connected with the threshold value. Now we will discuss the stochastic gradient descent. Basically the word stochastic means a system that is linked with the random probability. Hence in stochastic gradient descent, a few samples are selected randomly instead of the whole data set. And also in gradient descent there is a term called batch which defines the total number of samples from a data set that is used for calculating the gradient for each iteration. Now we will discuss the concept of max pooling. The pooling layer is the most significant rule in the pre-processing of an image, and it will also reduce the number of parameters when the size of the image is too big. Pooling is also known as the downscaling of the image processed by the previous layer, and it also equates with the shrink image to reduce the image density. So basically the main purpose of max pooling is to reduce its dimension, and it accepts the assumption to be made about the feature that's stored in a subpart. In the end, we will discuss about the LSTM model. LSTM model stands for long to short term memory. Basically, it is an extension of a recurrent neural network. It is handled to situation where RNN is failed. So talking about the RNN, it is a network that works on the present input by taking into a consideration on the previous output. So LSTM became popular because they could solve the problem of vanishing gradients, but it turns out they failed to remove it completely. The problem lies in the fact that the data still must move from the cell to cell from its evolution. They require a lot of resource and time to get trained and become ready for real world application. In technical terms, they need high memory bandwidth because of linear layers which is present in each cell. With the LSTM becomes quite inefficient. With this, we have completed the recommendation for neural network training.